All right, today we're looking at angles of rotation. So when we look at these angles, we're going to be looking at them on a coordinate plane. So the first thing we want to talk about is our angles have standard position. So when they're in standard position, that means the vertex is at the origin on our coordinate plane, and then one of the ray is on the positive x-axis. Then we have a couple other words to define. The terminal side of an angle is the angle, the side of the angle that's actually rotated. So we have the terminal side, and then the initial side is the one that stays on the x-axis from standard position. And then the last word to define would be angle of rotation, which is just the angle that is formed once you rotate that terminal side. It is important to note that the terminal side can be rotated more than 360 degrees, so we can go all the way around our coordinate plane and then some additional degrees. So we can rotate in a positive direction and a negative. So we're going to look at the positive direction first. It's important to note that positive rotations go in a counterclockwise position. So we have 0, 90, 180, and then this is 270 down here. Here's our initial side. That's the side that stays on the x-axis. Counterclockwise means it's going to be positive, and then that ending side of your angle is what we call the terminal side. Negative rotation then is in a clockwise position. Here we have negative 90 down here, negative 180, and negative 270. Your initial side stays where it is. Clockwise rotation gives you the terminal side over here. So our terminal sides are roughly in the same position, but we've gotten there in two different ways. So you're going to be asked to sketch. So we could draw a 60-degree angle in standard position. Well, oops, sorry, there you go. You can see it. We know that 0 is here and 90 is roughly here. So 60 is 2/3 of 90. So just a rough sketch would be a 60-degree angle right there. Remember, your initial side stays on that x-axis. We can also sketch negative degree measurements. So negative 135. That's going to obviously be between negative 90 and negative 180. So we're working down here in the third quadrant. We are 45 degrees past negative 90. So it's halfway between our negative 90 and negative 180. So there would be your negative 135 degree rotation. I mentioned earlier that we can have an angle measurement greater than 360. So here we're being asked to draw a 405 degree angle. Obviously that's going to be one full revolution around our coordinate plane, and then we just have to decide how much more. So 405 minus 360 gives us a 45 degree angle. So our sketch, we're going in a counterclockwise position. We go 360 degrees all the way around, and then 45 more degrees, which again is halfway between our 0 and 90. So this 405 degrees goes all the way around one complete time, and then halfway through quadrant 1 again. So that brings us to something called a coterminal angle. So a coterminal angle is just an angle that shares the same terminal side with one or many other angles. So our 405 degree and our 45 degree angle from the above example are coterminal angles because they both have that same terminal side. So you'll be asked to find different coterminal angles. So a lot of times you'll be asked to find one positive and one negative to a particular degree. So our degree is going to be 68 degrees. Well, one positive coterminal angle would be if we completely get around the axes again. So we would add 360 degrees. So we take 68 degrees plus a full revolution, which is 360 degrees. And that gives us 428 degrees. A negative coterminal angle, instead of adding that 360, you're just going to subtract that 360 because you're going in a negative manner. So 68 minus 360 degrees would give you negative 292. So both 60, or all three, 68, 428, and negative 292 are all coterminal angles because they all have the same terminal side. I would like you guys to find the measure of one positive and one negative coterminal angle to 124 degrees. Okay, one more thing we want to talk about is something called a reference angle. So sometimes we get really large angles and we need to gather information about that, but being so large, they can sometimes be difficult to find. So we're going to find what we call a reference angle that will always be acute. So remember, acute means less than 90 degrees. So your reference angle will never be larger than 90 degrees, and it will always be formed with the terminal side of your angle and the x-axis, no matter where it is on the coordinate plane. So if we look at a measurement of 155 degrees, remember this is theta, that just means angle. So our angle is 155 degrees. Well, that comes over here. 155 clearly is not an acute angle. So we need to find an acute angle that's formed with our terminal side, which is right here, and the x-axis. So it's this little 25-degree angle. That's going to be what we refer to as our reference angle. Sometimes they won't be in that first or second quadrant. So if our angle measurement is 240 degrees, that's clear down here in our third quadrant. Well, again, obviously 240 is not acute, so we need to find an acute angle made with with the terminal side and the x-axis. So our reference angle here would be that 60 degrees. Okay, and I would like you guys to find the reference angle for 99 degrees. Last thing I want to talk about, the other day we talked about trig functions, and today we're going to talk about trig functions, this time on an actual coordinate plane. So we're going to be given a point, an x, comma, y coordinate point that will be on the terminal side of our angle. So when we do that, we can always find our radius. So let me actually draw, because I did not draw this in our notes, but we're going to be able to find our r value, which is a square root of x squared plus y squared. It's Pythagorean theorem, which is where it comes from. And then we'll define all of these trig functions. So sine will be our y value over that r value we just found. Cosine will be x over r, and tangent will be y over x. Obviously, x can't be 0 because we can't divide by 0. But let's go through this example, and I will sketch a picture, so hopefully this makes a little more sense. So we have our point. It has the coordinates -5, 12. Well, if I go on my coordinate plane, -5 we'll say is right here, and then +12. Say this is my point on my coordinate axis. I know that's kind of small. But we have this x value, and then we have this y value. From the origin, you have this extra side, and this is what we call r. Okay, so this is our side length r. So then when we go to plug our numbers in, this we know is a -5, and we know that this y is 12. So we know by the Pythagorean theorem that this x squared plus y squared will equal r squared, and we're just solving for that here. So that kind of gives you a little background on where that r value comes from. But anyway, in this particular example, we're going to actually take that -5 squared and that 12 squared, add them together, that gives us 169, and then take the square root of that, which is 13. And then we can go and find it asks for all 6 trig functions. So above we define the sine, cosine, and tangent. So I just plug those in. Sine is y over r, so 12 over 13. Cosine is x over r, and tangent is y over x. Remember, the other 6 trig functions are just the reciprocals. So cosecant corresponds to sine, and that's just 13 over 12. Cosine and secant are related, so flip your fraction here. And then tangent and cotangent, you just flip your fraction there as well. If you need more examples of these trig functions, there is another one in your book that you can take a look at.